Again, pre-calc. Who are you? Well, all of a sudden, they're going to take a little interest in geometry. See if you can go back quite a few years and see if you can remember some of the things your geometry teacher taught you. So, we've got this crazy drawing here. There's only one number on it, and that is PB. Our hypotenuse of this little triangle is 1. Here we go. So, what is sine of theta? Well, there's my reference angle. Sine is opposite. And see, there's no numbers there. There's no way we can find it. So we're going to use just these segments over the hypotenuse, which is 1. So really, it's just BD. Cosine. Well, that would be adjacent PD over segment PD over 1, which is just segment PD. Now, here comes the geometry. Is the measure of angle A equal to theta? So angle A is way up here. So I am not saying that this is 30 degrees, but let's just say it is, because it looks like it. That's a big dangerous move in geometry. But if that's 30, this has to be 60. And as you can see, back to geometry, these right here, a tangent to a radius would create right angles. So that's a right angle, and so is this. I'm gonna make that more clear later, but let's concentrate here. So if this is 60 and that's 90, that means this has to be 30. I'm not saying they are 30. If this is 27, that's 27. If that's 26, this is 26. But is theta equal or congruent to angle A? Yes. All right. Now, is triangle, what does that symbol mean? It means similar. It means like making a batch of cookies. If I make one batch, 4 cups of sugar, 2 batches, 8 cups of sugar, that sort of thing. Is triangle PDB, P to D to B, this guy right here, similar to A, B, P? And if this is 30 and that's 90, which it is, that makes this 60. And because they have the exact same, they're not the same size, but they have the same degree measures, we would say yes. Now, what is sine of angle A? Well, that's taking us and saying into this triangle right here, and that is opposite over hypotenuse, which in this case would be AP. So that would be 1 over segment AP. There's no way we can reduce that because there's no numbers. Now, here comes some more geometry. Now I'm going to get rid of all these little gizmos here. And let's talk. Is triangle PBC, that's right here, I'm going to highlight it. Now notice, this is a 90, because it's the same rule as that 90. A radius drawn to a point of tangency, which is right here, forms a 90. That's a geometry rule. Is it similar to PDB? PDB. Well, remember, we said, let's just say that's 30. And if that's 90, this has to be 60. Now let's take a look at P. Where is it? PBC. Well, this is still 30. This is 90. That makes this 60. So we have another 30, 60, 90. Again, I'm assuming they're 30s, but that's a yes. All right, in triangle PBC. So that is concentrating on this triangle right here. What is tangent of theta? We'll have the opposite, BC, over adjacent, which if this is my hypotenuse, that makes this my adjacent side, so that'd be over 1, which is just BC. What's cosine of that? Well, cosine of that would be adjacent. See now, this is my opposite. This would be my hypotenuse from there to there. And this would be my adjacent, or 1. So adjacent, 1, over hypotenuse, PC. 1 over PC. Secant. Well, secant is the reciprocal of cosine. So that'd be PC, just flip this, over 1, which is just this. All right, different way of looking at math with a whole bunch of geometry. All right, back to trig. If you spin your spinner negative 2 pi over 3, which is 60 times negative 2, which is negative 120. So every picture tells a story. There's our spinner, down 90, another 30, stops right there. So if that's 90 and that's 30, that makes our reference angle 60. Here comes your review of 30, 60, 90s. Again, they don't let go of that. So this is a 1, this is a square root of 3, and that's a 2. I made a tiny mistake. Can you see it? It's right here. That's got to be negative. Left 1, down. Oh, I made another one. Okay, here we go. Now I've got my dimensions. I have to find secant of this picture. Well, I know secant is the reciprocal of cosine. So I'm going to find cosine and then flip it. So cosine would be adjacent over my hypotenuse. So secant would be that flipped, or negative 2. Tangent, opposite, negative square root of 3 over adjacent, negative 1, which is just the positive square root of 3. Now to find cotangent, I'm just going to jump right there. I have to flip this. So there's really an over 1. That's 1 over the square root of 3. Get that square root of 3 out of there. Square root of 3 over 3. Cosecant is the reciprocal of sine. So I'm going to find sine and then flip it. Sine would be opposite over hypotenuse. So I have to flip it. So that'd be 2 over negative square root of 3. Now, remember, the negative, just by habit, you can keep it up. Now you might say, well, the hypotenuse can't ever be negative. That's not my point. I'm just trying to simplify this. So now we get rid of that square root of 3, and I get negative 2 square root of 3 over 3. And there's cosecant. Now, a quick review of logs. Remember, we're always, on these situations where you've got multiple logs, you're always looking for law 3 first. Here's law 3, here's law 3, here's law 3. So how can we rewrite this thing? Well, that goes here, log of a cubed minus log of b squared. Remember, you can bring that up there. And then plus log of c to the 1/3 power. Now, you got to remember what subtraction means. Subtraction means the 2 shall become 1. Subtraction means division. So that'd be log. First thing goes in the top. Second thing goes in the bottom. Plus log of c to the 1/3. Now, I notice the book isn't too particular about this, but I'm going to throw something in here. What does plus mean? Well, plus means multiply. Multiply this by this. So I would get log of a cubed, remember this is like over 1, c to the 1/3 over b squared. Now that's the same thing as the cubic root of c, but I don't think they put it like that in your answer. I think they said good enough. Now we got a little doozy here. Remember PEMDAS? Clean everything up in the parentheses first. In other words, we're going to worry about that last. So I'm going to focus on this, clean it up. Here's law 3. So that goes here. And plus means multiply. So log ab cubed minus, I'm going to take that 2, I'm going to put it here. Log c squared. The 2 shall become 1. Subtraction means division. The 2 logs become 1. So I go ab cubed all over c squared. Here's the thing. We got this 1/3 now in front, which is law 3, staring you down in the face. So that means I can put it up here, and I'd get log ab cubed over c squared all to the 1/3 power. Now, I don't know if they left it here But what we have is a power to a power situation where, remember, if you have x squared cubed, I think I'm running out of space. I think I am. So I'm going to rewrite this right here. So log a b cubed over c squared. I don't know if this is cut off on your screen or not, so I'm just rewriting this right here. So, what I was saying was x squared cubed is x to the 6. We've got to multiply these powers. So there's a 1 there, so I get log a to the 1/3 b, 3 times 1/3 is just 1, all over c to the 2/3. They might have left it here, but I think they went to here. Either one is fine. There you go, almost done. Okay, this problem's questionable because, again, this relates to what we finished in Pre-Calc A. It's going to require that you know what a dot product is, but I'm going to kind of reteach it just in case we didn't get to it. But this question says, what is the angle between vectors 2, 4? Notice it's in component form, which means that it originates from the origin, and negative 3, 6. Again, these little pointy things means it originates from the origin, and it's asking for us to find this angle. All right, so this is our angle in this formula. Well, the dot product of vector u and vector v, basically the definition of dot product is you take the first, these are called your a's, and you multiply these together, so you get 2 times negative 3, and then you add your y's, or the product of your y's, 4 times 6. So it's simple, it's just weird looking and different, especially if you didn't get that taught to you at the end of Pre-Calc A. So it's negative 6 plus 24, which gives us 18. Now what's this symbol? That symbol's the magnitude. So how do we find the magnitude? Well, we're going to use this formula, which is just the Pythagorean theorem, because if I went like this, this is 3. If I went like this, this is 6. And we go a squared plus b squared equals c squared. So this is the magnitude of this vector right here. I'll just put a v with a magnitude symbol. It's our c. It's just the length of the hypotenuse. So we're going to square this, and we get 9. Square that, we get 36. So we get the square root of 45 times whatever the magnitude of this vector is. So again, that's 2 and 4, so we could use Pythagorean theorem, but I'm going to use this formula again. Square that, we get 4. Square that, we get 16, so we get the square root of 20. Now this is a mess. So we got to use our calculator, and here we go, on, clear. So I'm going to find out what the square root of 45 times the square root of 20 is. Remember, we can multiply these together. So I'm going to go 45 times 20. We could figure them out individually, then multiply them, but I'm going to multiply them together. And that is 900. Well, how convenient is that? So that's the square root of 900, which is just 30. So I get 18 divided by 30. So 18 divided by 30. And I get 0.6. So cosine of our angle equals 0.6. Now how do I go from this to actually answering the question? So we got to go like this. We got to go second cosine 0.6, and that will give us our angle. So here we go. Second cosine 0.6, 92. So my drawing must be a little, whoa, I must be in radians. I am. All right, that's always dangerous. So let's try that again. Second cosine 0.6. Yeah, that makes more sense. 53.13 degrees. There it is. New formula, dot product, review of magnitude. Maybe this is the first time you've seen that formula. All right, one more thing to show you. We're going to be done. All right, so here we go. Call this the ACT special, and this will finish the last unit before, or the last lesson before our quiz. We have a quiz next time we meet. First one's pretty easy, but let's read the instructions. If x squared plus y squared equals 1, so it's just a formula. Rewrite using only y. All right, so we got to get rid of that x squared somehow. Well, if we think about that, we go x squared equals 1 minus y squared. See, this one's pretty easy. So I got y squared minus whatever x squared is, and it's this. So I'm going to subtract all of it. So I get y squared minus 1 plus y squared. So it'd be 2y squared minus 1. That one's on the easy end of the spectrum. This isn't. So this is a doozy. Well, if we first look at this, we're like, whoa, we got fractions. It'd be nice if we could add them. That's right. So if this was a 2 and that was a 3, our common denominator would be a 6, which tells us, how do we get the 6? We multiplied these together. So my new common denominator is going to be 1 plus x times 1 minus x plus 1 plus x times 1 minus x. Now, how do I get to here from here? Well, I got to multiply this one by 1 minus x, and I got to multiply this by 1 minus x, distribute, so I get y minus xy. Do the same thing over here, but I have to multiply that by 1 plus x, 1 plus x, so I get y plus xy. Now that I have common denominators, I add the numerators, and you can see y plus y is 2y. Negative xy and positive xy, they cancel all over this common denominator. So 1 plus x times 1 minus x. Now here's where the fun begins. If I actually multiplied this out, because I don't know what x is. I know x squared equals this craziness. I could take the square root of both sides, but that seems like it's getting messier, not neater. So I'm going to go ahead and multiply this, and I'm going to get 2y all over 1, and outside, inside, you negative x plus x, and then minus x squared. Now notice what happens to these. They cancel. So I end up with 1 minus, watch this, x squared. Now look at x squared equals this. So I'm going to take that out, and I'm going to replace it with 1 minus y squared. So what do I get? I'm running out of space here. So I'm going to distribute that negative through. I'm going to get 2y all over 1 minus 1 plus y squared. These cancel, so I end up with 2y all over y squared, and these reduce to 2 over y. That is a tough little math problem. That finishes this section. If that's going to show up on a quiz or a test, that'll be a bonus. If you like this video, like and subscribe. Thank you.